Hey guys, welcome back to my channel. Today we are going to talk about the label distribution protocol, which is the LDP protocol that is used in the MPLS. Okay, this is a control plane protocol which is basically used for distribution of protocols. It is used for creation of protocols. Okay, it is helps in MPLS do the label lookups to choose the best possible path and forward the packet in that path. Okay, so let's see how the label distribution protocol works. Okay, so in LDP, let's say I have a host B which is configured with an IP address of 6666. Okay, now this route will be learned by CE2 as it's a directly connected interface. It will automatically learn the 6666 route, right? And then this particular between PE2 and CE2, let's say there is a routing protocol which is working. Okay, underneath there is a routing protocol which is working. Let's say it's called OSPF, ISIS, or EIGRP, or EBGP or whatever. Using some protocol, PE2 learns about 6666. Okay, and once this, so let's say this is /8 route. So this would be what, 6.0.0.0 network, right? So once this entry goes in the routing table, which is routing information base on PE2, right? And MPLS is also configured on PE2 and LDP is configured on PE2. So what LDP protocol will do is LDP protocol will create a label for this route. Okay. MPLS has its own forwarding table as well, which is called as label switching information base something. Okay, LSIB. So that will have the information about the next hop. It will have the information about the label which is associated to the next hop and the interface that packet has to go out. Okay. Now, as soon as P2 learns about this route 6000 and that is populated in its routing table, LDP will create a label for it. Okay. Now let's see. We have on PE2. Okay. I have a route 6.0.0.0. Okay. I'll have a local label and I'll have a learned label. Okay. Let's say the local label I create is 32. Okay. And what happens is this information will be sent to P1 saying that to reach 6.0.0.0, okay, you have to use label 32. Okay, and also P1 will create an own label for this particular route, and that will be, let's say, 31. Okay, now this locally created route label 31 will be sent to both P1 and P2. Basically it will be sent to all its neighbors. Okay, but P2 will not use it. Okay, because P2 already knows how to reach 6000 via 32, which is the CE2. Okay, but PE1 will learn that. Okay, PE1 will say that okay, to reach 6.0.0.0, I have to use label 31, and it will create its own label called 30, and that will be sent to PE2 and P1 again. PE1 will not use it because PE1 knows that PE1 has to use label 31 to reach 6000 network. Okay, now let's say host A is trying to communicate with host B. Okay, host A sends a packet out with the destination IP of 606666. Okay, CE1 will do a 6000 lookup. It will send it to P1. P1 will do a 6000 lookup based on the routing protocol working in the ISP. Okay, it says that P1 is the best route. It's a better route than P2. Okay, it will also see that on P1. Okay, this entry on P1 is basically to reach 6000. Okay, it has to use the learned label 31. Okay, and there also will be an action mentioned. So what PE1 will do, PE1 will push the label 31 onto the header. Okay, now this 31 will come to P1. P1 will see in its routing table or in the MPLS table, okay, that to reach 6000 it has to use 32. So it will swap 31 with 32, and it will send it to PE2. PE2 will see that okay, this 32 is local to it and it's connected to CE2 and it has to pop. Okay, so PE2 will receive the label with 32 and it will pop it over here, and then 32 is removed. Okay, and then it is sent out as a normal layer 3 packet with the destination address as 6666. Make sense? This is how LDP lookup will happen. Okay, so along with this, the action will also be mentioned over here. This will be pop, this will be swap, and this will be push. Okay, there'll be interface mentioned, and there will also be what do you call L2 header will also be mentioned. Okay, now let's say there are two parts, right? P1 has two parts, P1 and P2. P1 has given the local label of 31, and let's say P2 gives to P2 P1 a label of 35. Okay, so for P1 it has two labels now, 31 and 35. Okay, now based on the routing protocol which is running underneath, whichever determines which, basically that protocol will determine which path is better. So if it says 30, if it says the 35 path is better towards P2, then the 35th label will be installed in the table. Okay, if it says that the P1 path is better, then 31 label will be installed on in the MPLS table. So based on this routing protocol's decision, we will choose which label to use, and it will appropriately push the either 35 or 31 based on which path it has to choose. Okay, this is how LDP will create the label and distribute the label among each other. So it's basically it forms a hello connection. It sends the hello packets out to its LDP neighbors. So PE2 will send a hello packet out with P1 using UDP connection. Okay, once they establish that both are configured with LDP, they'll form neighborship. Okay, LDP neighbors, and once they form neighbors, they'll form a TCP connection and they'll share all these updates. Updates are basically the it will share that for this network use this is my label, for this network this is my label, please learn it. So this is how using the LDP hello packets neighbors are established, and once neighbors are established, LDP updates are sent, and these updates are the label information is exchanged. Okay, so you have a table with LDP neighbors, you have an you have an MPLS label database. Okay, you have a label database. It's basically like a routing table only, but with a little more information about the labels. So this is how LDP works, and this is how we use the labels to do a label lookup and forward the packet to the right path instead of doing an IP table lookup. Okay, so we completely avoid IP table and we use MPLS label lookup, so it's faster, it's much faster. People would prefer faster links, and hence ISP invests a lot of money in this to have this label MPLS configured on all the devices in their network and do a label lookup, save time on traffic and bandwidth. So this is why MPLS is one of the most famous technologies used in the internet, on the internet today. Okay, please do let me know if you guys have any more questions. Please like, share and subscribe. Thank you guys.